Thanks for coming for this tiring last talk for today, and thanks for inviting me. I'm Silur. I'm an independent consultant working in cryptography, ZK. I was an early Ethereum Foundation developer. Now I research quantum computing and quantum resistant ZK crypto at the Web3 Institute. I managed to get couple co-founder titles from my prior independent contractor client because they take me on a CTO for some reason. And I co-organize CCTF, which is like a cryptography Web3 CTF game. Taking place twice a year. Okay, it works. So on the agenda, we will have the definition, the PMF for account abstraction. Why did we have to invent it the first time? Then prior work before AA. So it's not the first time we thought about contract accounts and how to make the UX hurdles a little easier there. So I'm gonna list all those, then tackle why those didn't get to be the standards and why are we going towards the one that now is going to be the account abstraction standard after so many times. Then I will break down the life cycle of a usual account abstracted transaction. Does it time out if you don't touch it, maybe?
Well, I don't know, it was working properly earlier, so I really don't know.
Okay, so we'll break down the life cycle of an account abstraction or abstracted transaction. Currently, then I brought you some fresh statistics from multi-chains and Ethereum-specific numbers on the adoption of current abstraction models, best use cases, and how big companies are trying to use this. And of course, as promised in the title, being a hacker, I will break down the security implication of this new threat model that comes with your wallet is actually a contract on-chain. So where we are now, everyone knows, currently, the main problem, all the problems that I'm gonna list as solved here stems from the single fact that whatever happens on-chain has to originate from someone pressing that magic button on MetaMask. So you have to sign a message in order for anything to happen. There are no automatic stuff on-chain. There are no cron jobs, no VAT hooks that happens automatically. There are no recurring payments because you can't say that at this time of the clock something has to happen. Everything originates from someone signing a message. And we just managed in 2023 to get developers understand this. So with all the hacks that happened because of the faulty threat model, because even developers couldn't get themselves to think in a transactional way, because Web3 is mostly not transactional. Web3 is. We now managed to do this for devs. Now we have to do the same for users, and it's gonna be much harder. And that's what we tried since the beginning from Ethereum. So when I was still Ethereum Foundation, even then, the early days, the problem was already formalized. That yeah, EOA is good, but if we have to incomplete contract, that would be so great to have like multi-sigs and arbitrary logic on the contracts. Problem is that those introduce not just developer hassles, but UX hassles too, because you still need to pay for the gas, and you still need to sign a message, and you have to be aware of gas limits and gas costs of a transaction, and we did learn that people are not really good at that. But it's not a new thing. So at that time, there were two main ways to solve this problem. One was account delegation, which is kind of a forgotten way. It's likely not going to be implemented at all, but it's an interesting read in the EIPs because it introduces new opcodes. So you can delegate signing capabilities to a contract. That's one way to tackle this problem. But now we're talking about EIP 4337, the AA standard that's going to be implemented, and it's all over the media now, which is the account abstraction model. So prior work and the current EIP we are talking about depends on many of these, and you can see that there is EIP 2938 written by Vitalik in 2020. The first iteration, it's a more generic version with the PMF, like the definition of the problem and the high-level solution. And ever since, the middle, what you can see between 43, 37, and the prior one are dependencies of those. So it was huge work to make this happen. But all those induced, as I said, high complexities for the users, so even more. We did make all the developer checklists that, yeah, contracts are now, or wallets are now contracts. I can lend NFTs in an automatic way, but in the end, I still have to originate something from an EOA. So that's why with the main thing about this EIP, the current account abstraction model is a second mempool, which I was actually very against in the whole development cycle, because when I was EF and I built a couple of other layer 1s and layer 2s, the mempool is like an especially tricky component to code. We barely can manage a single one currently, so I was kind of against the idea of introducing the second one, but it turns out it's very understandable. So first I'm going to go high level of an AA transaction, and then I'm going to break down. With the second mempool, it works exactly like as blockchain right now. We renamed transactions to user operations. So when you click around on the dApp, you're not making direct transactions to MetaMask anymore. You collect user operations. That, as usual on blockchain, gets collected, but now we don't call it a miner, we call it a bundler. User operations will be collected in a bundler, who's going to verify some stuff on it, and the bundler is going to make the EOA for you, so you don't handle private keys anymore. You just do intent-based transaction. This is going to be important later on. So you just specify your intent to the network, not direct RPC exact requests anymore. And they're going to handle all the security of the private keys and the mnemonics that you can't do. Okay. So the bundler is going to handle all those. They're going to call an entry point contract, which I'm going to specify why that's necessary. It's a contract that will call the call data of the smart contract that you are actually trying to access, your wallet that holds now the assets. Your private key doesn't have the assets anymore. And optionally, these are just like cherries on top. You can aggregate transactions to save gas, and you can ask a paymaster to pay for your gas in fiat, an ERC20, or if you have some other kind of deal of the sponsor, the paymaster, then not pay at all, and they're gonna pay for the network. So how could you have invented account abstraction? We need a smart contract wallet that's contrary to Solana account abstraction. Shouldn't work in a way that I have 10,000 functions, and when I want to access something, I have a specific bytecode for everything. I want one wallet from which I can interact with any other smart contracts inside Ethereum. So that means I need a struct that looks exactly like an Ethereum transaction, especially if you API encode it, and I have one function which is execute operation on-chain according to this. So we basically proxy ourselves from MetaMask to on-chain. Problem with that will be that you still need to call this execute operation with your externally owned account. So what you do, you ask for outside help. You're gonna ask the bundler for a favor that, hey, I assembled and signed the transaction, or not signed, you're gonna do an ECDSA, but not with your very sensitive mnemonic. Or you can implement, actually, the bundler can enforce any other kind of authentication, maybe biometric or Facebook. So you can call this bundler to, hey, I assembled the transaction, please submit it to the network because I can't handle my private keys or I don't have money for gas. And he's gonna interact with the network with this. And you promise at the very beginning that, yeah, sure, the contract that I'm gonna call is gonna pay you back for the gas, 100%. Problem is, we don't trust like that, we verify. So that in the next iteration, how we could have invented this whole thing, because I'm a bundler now, let's step into the perspective of the bundler. I don't trust anyone on chain. You promise me that you will pay me back for the gas if I send something to that contract. Who knows whether that's going to happen? We need another smart contract for that, which we call the entry point, and the Ethereum Foundation implemented this. So I ask the bundler for a favor that please forward this transaction to the network, but through the entry point, which ensures that if the transaction fails or whatever happens, you're gonna get your refund. You're not gonna be screwed over. And then this entry point contract calls another contract, which is your wallet, handling your assets, or the swap, or contains arbitrary logic with your assets. So the cherries on top is that the bundler and there is the bundler and the paymaster. So the bundler can potentially aggregate tens of thousands of transactions, user operations in this case, into one single transaction, and only pay the 21,000 gas fee once for it. So it's kind of a roll-up. It's like roll-ups included. It's not the same kind that you have on Polygon, but it can support it, and we can change the signature schemes. The bad part in this discrepancy in ZK research, because blockchain did create a huge increase in zero-knowledge and cryptographic research, but back then when Ethereum started, 2015, it was only ECDSA. Like, we didn't have like very fancy ZK and group signatures and ring signatures and stuff. And it would be really, really cool to finally start supporting some exotic threshold signatures in like BLS for these roll-ups. So like 10,000 transactions in one. But that needs a fork, and forks are like a natural catastrophe on chain. But with the account abstraction model, because the bundler is an off-chain service, they can like do any kind of authentication, maybe BLS, and you just verify it with the BM curves that already exist on Ethereum. So you can verify this. But the even more important part for end users is this paymasters part. They can pay for your gas costs. Like, people are so angry about the increase in gas costs, and they're very present because they can't get around it. Like, is the internet paid? Like, I want to go on a website and I have to pay. I remember this because this was my first question when I attended an Ethereum meetup. So is Facebook's gonna be a paid service? And when I encounter new users now, they still ask the same. So being able to say that, you know what, you use our service with your credit card, we're gonna handle all these gas limits and stuff. Or maybe even free. Or crypto savvy people can do it with an ERC20. So you don't have to buy it first. Many of my clients actually do try to enforce this logic through me that, hey, yeah, our clients do have money to invest, but they are not very versed in crypto, and it's a hassle for them to buy ETH, so they just give us cash. I'm gonna buy the ETH, hand them the wallet. It's like very, very common, especially in low liquidity. ERC20 is launching newly. So getting support for this from the network is really, really cool. So some major use cases, as I said, transaction batching. Some old use cases, if you remember Gnosis Safe, that's like one of the first examples of contract wallet way before account abstraction. It's a non-standard contract wallet. They implemented the multi-sig themselves. But that's one of the earliest use cases for it. Intent-based transactions. If you attended the first talk today, the composable call protocol, that's kind of the same. You don't do exact calls to Uniswap anymore. That I have this amount of USDT and I want to get that amount of ETH. You can get intent-based that I have this amount of USDT, I want the most ETH I can get for it. So no exact calls anymore. Then you have recurring payments, for example, which was also like a very, very hot topic with my clients, like subscribe to on-chain content. Key recovery. I don't particularly like that because I am mostly a Web3 security guy, and the trust model is a little skewed for that, but I do sign that people are not used to the Web3 type of threat model. Like HMAX and Memnonics and protect your keys, they are more used for someone else to keep those. And social recovery, like Facebook, Twitter, Gmail, you send a forgot password request, I forgot my name, and we're gonna change it inside your asset contract.
How does that work?
Your wallet, your smart contract wallet, has like the same way as now, ECDSA6 or some other kind of authorization method, maybe just a public address field called me, like forgot address operator. that has a single call that if I have a signature of yours from a recovery account, I can change that field, like your original from field that we allow in the user operation. So if you lost your AUA account, or if you lost mnemonics and stuff, you can ask, because you're not directly operating with the smart contract anymore. You can ask the bundler, the paymaster, or the service provider, me, that hey, send me a link where I can specify you another identifier. Maybe it can be even a zero-knowledge proof of membership for the service. So it's a free field, it's an address field inside the contract. And if you implement a modifier on it, that who can modify it, it's not just you anymore, finally. You can do a multi-sig even. I give you a recovery address, and you need both of us to change your actual transacting address. So you can just have me. It depends on the providers. That's the beauty of it. It can have arbitrary logic for lost keys.
Why don't you like it if you could like mix that?
Centralization. Like most likely it will end up with Facebook being your primary way to Web3, and I really, really don't want that. Like people to start mixing the threat models and start trusting Facebook and Google recovery emails for the keys. I just don't want that misconception to
But this
happen.
is now insured at smart contract level.
Sorry?
Isn't all these insured at smart contract level? So even if it's Facebook or Twitter or another,
Yes, it is.
it's like.
Yes, it is, but the user won't be aware of that. It's the same as like if you go to like a sketchy website, you're only gonna use your Google account for that, and you somehow, like normal users, mix the threat model between the two. If there is Google integration, then they think that they are working separately on that, and I don't want that to happen with Web3. Like mix together Web2 and Web3 security in your head, because they can't get Web3 security in the very beginning. So mixing in Web2 and start like passkeys. Yeah, passkeys actually, okay, that's an exception. That would be really good, because MetaMask is basically passkeys before it was cool. You sign a message and stuff. But long story short, I don't want Web3 security misconception leak into Web2, like make a weird, monstrous blend of them.
So it's more about like the conception than.
Yeah, it's a technical stuff. Like I do see the user base and the user experience value of it, and that's why I'm not against like 100% should make it to the wild. It's my personal security ethical hacker soul that's kind of against of making people more confused about Web3 and Web2 security here.
Could I just try to understand that really quickly on the social recovery side? Is it like the person's going to have this wallet and they're going to grant some person over here control?
They can.
This is the wallet that's actually doing shit.
They
You
can.
can like recover it. It's
Yes.
Facebook or whatever. Use this guy.
Yes.
Is that right?
And you can have arbitrary logic for it. So maybe sending a token, a redeem token through email for it, or YubiKeys, maybe. And also lending during NFT times, it was a huge topic, like especially in gaming, when like people were renting Axies, because Axies became so expensive that agencies started to buy the $200,000 Axies, lend out to Filipino people to play with, and the money you made, then you give back the Axie to me. It was crazy, but you couldn't really. There was no native NFT lending technology out there, and many people started to implement this their own makeshift way. Now it's gonna be a native feature for that.
So when asset lending, you actually mean like more like allowing them to borrow some of the rights or usage associated without taking control of the asset.
Or straight up borrow the asset. So with account abstraction, I can really say that I'm gonna send you this NFT, but you can only use it for 30 days. And after 30 days, you don't have the right for it anymore. In the current model, that can only happen if after 30 days you sign a message where you wow all rights from that NFT.
Sure.
With this one, you can't do that anymore. And it creates a whole different ecosystem actually, like a whole different flow of the ecosystem in this way. So on the next one I have some fresh numbers. This is from all EVM chains combined. 2 days ago we made 2 million successful UserOps, hooray! From which it's very interesting because Account Abstraction, the first and the last one was written by Vitalik, but half of these 2 million UserOps is on Polygon.
This including safe transactions?
Safe transactions, like internal ones, you mean?
No, safe transactions.
Gnosis safe? I don't know. No, most likely not. I saw the June query for it, and I didn't see any of that. So no. Yeah, I'm kind of sure this doesn't include those. So half of the 2 million UserOps that happened is Polygon, and Ethereum only has 3,000. Their entry point contract recently got audited by OpenZeppelin, from which I brought most of the security issues, because I brought it into 2 segments. So one last thing about mass adoption. Visa has been following the current account abstraction plan very closely and already published a kind of research how they are going to use it for recurring payments on-chain. It's very interesting. So security issues solved, first part that you're likely not going to see if everything is implemented correctly. But of course, there's going to be smart contract issues. So the most hot topic, the biggest problem we have right now is transaction ordering and MEV, minor extractable value. Because of the presence of the bundler, we are not likely to see that anymore. First reason, because miners don't only have access to the block production anymore. So it's kind of like a makeshift poor man's MPC protocol, because the miner collects already bundled transactions from the bundler that they don't have control on. Second, the bundler can't control it because the window, like the bundle size is much smaller than a block. So you don't really have much playing space with the order of the transaction as in current blocks in Ethereum. Miners currently have the sole power of ordering your transactions, but with bundlers, because they already contain already signed and authenticated user operations, it's a 2-party process to assemble the final ordering of the transactions. So if you want to do MEV, at least you have to be a bundler too here, because it's a 2-party process, but there is no guarantee. There is no guarantee that you're going to be the bundler for it, because the user can select you, and that's where competition happens. Like
why can't bundler get MEV?
Sorry?
I didn't why MEV is not transferring.
Because the user selects you for the bundling. It's not like in ETH that you compete for the user's blocks, or after the new upgrade happens that you rent out your space for the user blocks. It's the user will have to select you. So even if you are a super big bundler and a super big miner, there is no guarantee that the particular user whose trade you are interested on to front run is going to be selected in both the bundling and the mining.
No, but even if it's different. Because, okay, so the bundler is submitting transactions that the miner is ordering them.
Yeah. There is no guarantee that your user operation bundles together in a TX is going to be front of what you are targeting here anymore.
Okay, but maybe the bundler is submitting like 10 transactions, but one of them is subject to MEV, so there will still be MEV from the miner.
Again, please, this one?
Like maybe the bundler is bundling 10 like transactions into one,
Yep.
submitting them only with one transaction, but then the miner or the validator just like take one of these and I don't know, some just like that one, for example.
Yeah, that's not gonna go through the authentication because bundlers are also verified. So if you like modify halfway the user revelation package that's already signed, and you take out something or sandwich or insert or change the order, it's not gonna be.
But you don't have to, like, because you have like transaction 0 that is like the sandwich tag, then you have like the 10 transactions, and then the rest of the sandwich is happening like on the 11th transaction.
Yeah, so
Still a sandwich tag.
so it still doesn't manage to get through the discrepancy between the bundling and the
But
mining.
I'm just saying it's not like changing that sandwich.
It does.
Yeah, I agree. I think they're going to tend towards being the same thing.
Like sandwiching and
Where is a
everything.
bundler? They're bundling as a service.
I think
So it's going to end up being the same thing.
I think being the same thing, I'm not sure if that's going to happen because if the user chooses a bundler, then they're not going to choose those that exploit them because only basic is part of my users. So if there's a bundler,
The whole thing, I have a slide on that it's gonna actually create a reputation network on the whole thing, which is always gamified. So that's one of the security issues we actually introduced into the network. So let's quickly get to that because it seems it's like a hot topic here. So okay, go through the security issues. So timestamp randomness, again for the same reason, because you are not the only one putting the timestamp on the blog, but there is the bundler now involved. You can't exploit timestamp randomness. Address validation. If you have a too short address because of the API coding, Ethereum, like Solidity, will pad it with zeros, and that can lead to security issues. You can't have that anymore because the entry point contract can enforce correctly formatted addresses for colors. Gas balance and reentrancy. Reentrancy will be the big thing here. Is because of the paymaster, they can introduce the, for example, the Open Zeppelin non-reentrant call, because you go through with smart contracts to your wallet contract. The entry point can protect you from reentrancy here. Trapdoor contracts from the bundler. There are many services very popular nowadays that simulate transactions prior to actually sending it to the mempool. If your bundler service implements that, then you're protected against trapdoor contracts, and you should select in the future a bundling service provider who has these simulations integrated for you, which are not always right because you can still play with simulation, but it's better to foresee with a little uncertainty than not foresee at all. Self-destructs are a little tricky here. The entry point does protect you from it, but removing self-destructing contracts is already on the roadmap of Ethereum upgrades. Which was the last one? What? Oh yeah, transaction origin manipulation. Yeah, true contracts are also tricky. They're gonna be merged with account abstraction, so you can't like do a smart contract type, smart contract origin with a faulty fallback through these ones. Come on.
It's running on the Ethereum blockchain.
Yeah, it's bundling.
There we go.
Hey, sorry about that, guys. Really weird. See some strike.
It's an apple.
And it belongs to a French person.
You fixed it. What was that supposed to be?
Like some strike. Like.
So security issues are actually very nasty and complex ones, of course, are here to remain. Business logic, love bugs, you can't get around those ones. Type errors, also API coding, jeez.
I touched the cable. It's gonna blow. Didn't happen.
So yeah, block hash and other type of randomness, so not timestamp ones, you can still do. Empty account denial, I'm happy to actually, I only realized from the previous talk here that Ethereum already has it on the roadmap to finally empty non-used or empty accounts on chain. So currently there is the issue that if you have even empty accounts get included in the state tree, so you can kind of flood the mempool or like the storage of all validators with the empty accounts. and it's gonna have to be included in stage 3 validation. Okay, it's logarithmic, but it still grows. That still remains. Stack limit denial of service, also here to remain uninitialized variables and calls that if you call them twice, return 2 different values that are also here to remain, and yeah, of course, type errors. So the interesting part, where the questions came from, I wrote it into 2 slides because the first one are the ones I could remember from my head, and turns out it was absolutely not complete because then I checked the OpenZeppelin audit on Ethereum Foundation's current entry contract implementation, and it had much more critical issues that I couldn't figure out at first. And the first one is that it's a complex concept. So what I did here, that's why I made the talk here, we needed a primer for that. That's already a security issue. So it complicates account abstraction, the whole concept on the user a little more, because mutually untrusted parties in a bundle now share transactions. It's the same as with blocks through MEV. So you do the same in conventional blockchain terminology now, and now you do it a second time with the bundles. And it's hard to get your head around it as a dev and as a user for that. Then authentication is now 2 separate things. One happens in the entry point contract, and then the bundler does its own, for whatever way, biometrics, ID cards, passwords, passkeys. That's also something that when you think the conventional way that the blockchain protects me because it's the blockchain, now you have the entry points and the bundler services which implement conventional cryptography and authentication. You kind of have to forget that if you use off-chain account abstraction. If they are validated in a Web3 compatible way, for example, PLS signatures on the precompiled curves, then it's fine. But if it's any of the more exotic ways that I listed here, it's not. Third, paymasters and bundlers, the whole thing will create a third type, or maybe a fourth. There are many types of gamified markets on Ethereum that we didn't think of. The original yellow paper thought that only block production will be a gamified economic environment because you're going to compete for the gas. But then it turns out that you are also fighting for the ordering, the whole MEV thing. And now another unrelated upgrade for account abstraction realized that we actually have 2 markets inside Ethereum. So how about the block producer rents out his space in the block to other people so they can compete? So it's a secondary market, and with this, the paymasters and the bundlers, you're creating a third one, because now they also follow reputation market, and they're gonna gamify the system so much to get your block here. For example, to mix the discrepancy between block producing and bundles. So if they manage to gamify that, then they get back to MEV again. And both devs and users have to be very aware of this.
We use for mixing services as well.
Yes, yes. We actually had a great talk about that. Yes, it is. Because authentication can be a super strict zero-knowledge authentication if you want that. Third, account abstracted wallet need their own replay protection. I mean, MetaMask already has the warnings for nonces and stuff, but here you need to be a little more careful about that. You can't really calculate gas cost for your transaction prior because you are not the one actually making the transaction at the very end. You don't know how many other transactions are going to be in the UserOps, so you kind of have to rely on the bundler here. You can try to simulate through one of the services I already mentioned, but simulations are not always correct. So you can't get an exact gas cost calculation of your transactions anymore, or your UserOps anymore. I have to get familiar with the terminology.
The legal bug is explain the first one, which trusted parties. Can you explain it?
It's the same that you have currently in blockchain, the the whole EVM picks all the state changes in a row, because prior you swapping my tokens, my ERC20s, my tokens have to arrive to you. So we are mutually untrusted parties interacting in the same block. So it's super important that we get picked up in order for you to be able to swap, especially with flash loans. Like, everything has to happen in the same block. With UserOps, the problem is that because the bundler makes a single transactions, he also has to make sure all of this a second time. And the user has to be aware of that. Like, does the bundler actually handle this responsibility or not? Because you use the Ethereum Foundation validated and audited entry point contract, you can be kind of sure that it will stop if any kind of tricking like this happens. But you are not obliged to use that audited smart contract. So you can be kind of scammed to use another one here and fished to use another entry point contract. And it's really hard to make the user understand that now this ordering stuff and this trusted party is doing something happens twice. Because the first layer, the blockchain gets it. That's the whole thing, that the blockchain verifies it and it's not going to go to consensus anymore. The bundlers don't have consensus between themselves. Like, you send your UserOps and it's a Web2 thing. They're gonna do magic behind the curtains. Yeah, I have your bundle here, I'm gonna send it to the chain, but you don't really, like, unless the entry point contract rejects it, you don't really know whether it's faulty or not.
It's like you've invented layer 0.5.
I don't.
I feel like but this other.
Yeah, it's a funny way to call. Yeah. So the even more interesting ones, if the these are all specific to the paymaster, which is an optional component of the whole thing. So I ask someone to pay for my gases. Turns out from the Zeppelin audit on the entry point that if the paymaster fails for whatever reason, the end user still gets charged for transactions, and the paymaster didn't pay for anything for the gas. That's the crazy thing that shouldn't happen on blockchains, but because of the complexity of the whole thing, it does. Second, it's not just the paymaster screwing you. You can also screw the paymaster, because it has hooks, like post hooks, that everything happened correctly. It has to call this post operation, and you can kind of play with this post operation to always revert, and you can accusate the paymaster on chain that, hey, he didn't do his job correctly because he didn't call the post operation. And for example, a swap with an account abstracted wallet will check for this post stop to happen before swapping your stuff. And you sent all the money, everything happened except for this post stop. And you can accuse the paymaster that, hey, he didn't complete it. And because it's a reputation network, a gamified one, the paymaster is going to lose reputation in the network because of this. Third, funds in paymaster account abstracted wallets are separated into two layers, but that's only technical. It's only on code level. Conceptually, they are the same, which means that the paymasters can kind of mix these two pools of your money, one for simple attack prevention and one for your actual operation that you are trying to do. If they mix the two, you're not gonna know like how much, if you do 50-50 for the two, like simple attack protection and your actual operations. If it changes to 80-20, you're not gonna be aware of it. And also, token transfers, if they are not explicitly implemented with the Zeppelin revert type failures for ERC20 transactions, an ERC20 sending can fail without trace on Etherscan. So you're not going to be aware that one part of the transaction actually didn't go through the whole account abstraction model. You're just going to be left in the dark that why the swap or the compound withdrawal didn't happen, and it will have no effect on chain. Maybe only on Tenderly if you are able to read solidity, then you're gonna see that, oh, this last return value was actually false and it didn't revert. So there are gonna be, I think, even gamified, again, attacks with this stuff that finally things, or like not finally, like unfortunately things can happen that's not visible in the Explorer. So conclusion, account abstraction is the cool thing. I personally think that it's been years and years since I was EF that people were ranting about the killer app, the mass adoption, the key to it. This really might be the key to it, because handling wallets is the biggest hurdle. The entry point is the biggest problem for mass adoption. This could be it. But as a security guy, it's inherent to tech. It's not a Web3 thing, it's a computer science thing. Good UX means less security. That's all. And it always comes last. And because Web3, especially inside the tech space, Web3 is especially competitive. Usually you have 6 to 9 months in IT from idea formulation to reach market. In Web3, it's more like 4 to 6. If you don't do that, someone else is going to do that, which means you don't have time to implement high security that I would love to see. And many of the providers, bundlers, won't have that. It's just a personal opinion, but this is so far what happened every time when a technological innovation happened, and it's going to happen with AA too, because it happened with bridges, with multi-sigs, with zero knowledge, with nodes replaced. It happened all the time, and it's going to happen again. So expect a bunch of AA hacks either out the wild or on the CCTF competition. Thanks for your attention.
More questions? What timeline do you see until actually,
I don't actually.
like, cause there's like, yeah, a lot of hype right now, and like,
I really don't remember the official, whether there is even an official timeline for EF to like finalize everything. I'm not aware, and if there is, I have no idea what's the end date for that. So like a couple of protocols went ahead, and it's existing on Polygon and Starknet. Starknet's AA is kind of cool. Yeah, I advise people to check out the code, not because I'm chilling the project. It's just they implemented the majority of the complexity in Cairo before the Ethereum ones. So yeah, quite some protocols, and that's why I wrote the numbers. I was also surprised that 2 days ago we reached 2 million UserOps. I thought it's gonna be much less. So it means both the devs are already there, like implemented entry point contracts and AA wallet contracts. That means there is a front-end part, so that's already out there, and users managed to understand it to the level that we have 2 million UserOps. Yeah, that's cool. Okay, thanks again.